Hi students, a very good evening to all of you, and this is a channel, a good platform, and this is a channel, and we are going to learn the best concept in 10th class. So this year I'm going to start for 10th class peoples, and I want to start and the most important chapters in the physics. The main chapters are reflection of light through curved surface, refraction of light curved surface, and human eye, and also electric current, electromagnetism. Out of 5 chapters, so the most of the students may confuse about 2 chapters. One is electric current, other one is electromagnetism. So I want to complete each and every chapter in chapter wise, and I want to start the first chapter in the 10th class is electric current. So first of all, so I introduce myself, and this is a Siva Academy. I'm going to teach physics classes not only for the 10th classes, and I'm going to start already I have started IIT foundation classes. The peoples are students who are studying IIT classes in the childhood or otherwise in school levels, and the classes are very important, and we have to enroll, and we should enroll my course so that we can get knowledge. Okay, and first of all, this is a YouTube channel, and this is a platform where we can learn a good subject. Okay, and this is channel. And one more thing I have to say that, so everybody, and this is the channel, and everybody we have to subscribe and share it, and so that, and also one more thing, we have to click on the bell icon, so that we get notifications. So now I'm going to start new chapter in the 10th class, that is the electric current. Okay, definitely at the end of this session, definitely, and you will enjoy the my concept. And if you understand this entire concept, and and you share it and to the others, so that they will be benefited. And this is the only the free platform classes. And if you want to learn the IIT classes, IIT foundation classes and basic classes, and we should enroll your name, and definitely, and you will be benefited. So I don't waste my time and your time also. I'm going to start electric current, that electric current. So in this entire channel, entire concept, entire chapter, and I'm going to start. So what is the electric current? So before going to start electric current, we should know, and in the previous knowledge, that is in the 8th class, we have studied about the lightning. What is the lightning? Lightning. Generally, that lightning was happened in the sky. So whenever the lightning is happen, so there is some reason is there. The charge is discharged. While the charge is discharged, you may get lightning. So already you know that because of only the discharging of charge, you get a lightning. So everything we have studied in lightning, but in this chapter we are going to study the main concept is that their charge. Now, what is the charge? How many types of charges are there? And what is the properties of charge? And what is the reason? Who is the root cause for the electric current? Everything will going to start. So, actually current. So the current is the flow of charge. Okay, now. So now the main root cause for the electric current is a electron, that is the moment of charge. So where did you get this electric charge? Everything we are going to learn in this chapter. Okay, yes. So before going to start here, and if you take an atom, so you know all of you know the atom in the chemistry. So atom, this is my atom. The central part of the atom, that we call nucleus. The central point of the atom is called as a nucleus. This is a nucleus. The nucleus consisting, this is total nucleus. A nucleus consisting, the center part is called nucleus. The center part consisting of two particles, fundamental particles. They are called a proton and a neutron. Proton and a neutron. And one more charge, one more subatomic particle is there. that a particle is an electron which is revolving around the nucleus. So we know that the construction, we know that the atom, if you study the atom, it consisting of different types of orbits. S orbital, P orbital, D orbital, you know that here. Okay, so I'm not going to discuss everything in the atom because it is not a chemistry subject, but we are going to study about the charge. Okay, right, this electron which is revolving around the nucleus. So here there is, for example, it consists in different types of orbitals, S orbital, P orbital, D orbital, like this here. Okay, the electrons in the outermost shell is called as the free electrons. The free electrons means nothing but here which is loosely bound with the nucleus, loosely bound means here whenever we are giving energy to the electron by any method, so definitely which is ready to jump, from the atom, that is a free electron. Okay, and before going to that here, and I'm going to discuss the charge. So for example, and before going to start the charge concept here, and we should know materials. For that we should do the activity. The one of the activity in the textbook, that activity is that here activity number 1. The activity number 1, in the activity number 1, and he has taken one battery. So one battery, okay, and one LED, and a copper wire. The copper wire, you know that already we have studied in the previous classes. The symbol for the battery is the, if you connect the cells in series, more than 2 cells, that is called as the battery. And this is like this. So one larger line that is indicate the positive terminal of the battery. This is negative terminal of the body. Short line which is represents the negative terminal of the battery, and this is the cell. This battery nothing but if you connect these cells in series, more than 2 cells, that is called as a battery. Okay, this is the battery. Okay, yes. So now I connect the battery by wires and also connect the LED bulb. I complete a circuit like this. In which we have battery and LED bulb is there. I connect the LED and battery by using copper wire. So what do you observe? Definitely the LED bulb will glow. Okay, right. Now the second case, this is the first case number 1. The case number 1. So we have connected everything. So this is a circuit which is consisting of battery and copper wire and also LED bulb. If you connect all the components, they are called as electrical components. If you connect like this, definitely the bulb will glow. The next case number 1. So this is the LED bulb. Instead of, now I want to remove the battery. I have to connect the bulb with a wire, and I will complete the entire circuit with the copper wire. So in this case, the case number 2, the bulb will not glow. Yes. Third case. The third case is, so I have used a bulb. Instead of using the copper wire, I have used nylon wire. In this case also, and we have observed that the bulb will not glow. So this entire activity, we should understand that the first case, the bulb will glow. The second case and third case, the bulb will not glow, because here the battery itself which provide the energy, which gives the energy, and so this is a conductor. Copper is a conductor which is having the free electrons, That means here, so for example, if you see the atom, any solid body, this is solid body which is consisting of different number of atoms like this here. They are constructed in terms of lattice point. For example, this is a one atom, second atom, third atom, like this they are having. So this solid body having atoms like this here. Okay. right? So this is having the free electrons are there in the outermost shell. Whenever they are having energy, definitely they are jump from the atoms because they are loosely bound with the nucleus. They are called free electrons. So the moment, so when you give them a small amount of energy by battery and electrons which are present in the conductor and they are flowing through bulb and they complete the circuit so that a bulb will glow. And second case, there is no energy providing. So all we know we are providing conductor. So even though we are having the electrons because of absence of battery provides the energy. Okay, that's why the second case the bulb will not glow. The third case, so we are providing battery and LED bulb, but here, so this is the battery provides the energy to the electron, but nylon does not have any free electrons, so that the electron will not provide the path for the current, so that in this case bulb will not glow. So from this activity we can say that, so who is the reason for the reason for the carry the charge, who carry the energy, that is electrons are the root cause of electricity. Okay, so in the first case the copper conductor having the free electrons and we are providing the energy by cell and the electrons, so it will take the energy and it can move, it will move and pass through the LED bulb so that it complete the circuit, the bulb will glow. So that here, and we have from this activity we can say that materials can be classified into two types, mainly as for the 10th class knowledge. So it has two types. Actually we have conductors and semiconductors and insulators. As for your knowledge, and we need to classify only two. One is the conductor, one is the insulator. One is the conductor, next one is the insulator. Conductor and insulator. What is meant by conductor? Conductor is a material which allow the current, okay, and it has a free electrons. And insulator does not have any free electron, does not allow the electric current. Okay, that is the only difference between the conductor and the insulator. If you want to and pass the current any material, that material has a free electrons and that material is a conductor, that material is called as a conductor. So now from this class we need to understand, and if you want to pass the any electric current, so we need to use the conductors like copper, aluminum, silver. Okay, actually the good conductor is silver, but we are not using silver because it is very cost. In the cost point of view, the cost of the silver is very high. That's why we are using copper wires or aluminum wires. For the high voltage purpose we are using aluminum, and for low voltage purpose we are using the copper wires. Okay, right, this is about the accurate number one. Already this is there in the textbook and we have to read. Okay, right, next one. Just I said that here, when the when the charges are moving in the conductor, so that there is a current is flowing. Okay, now I'm going to tell you. So which charge is nothing but, so what is the charge? Charge is nothing but it is a property of the material or matter. It is a characteristic, it is one of the main characteristic which is developed in the matter, so that because of this property, because of this character, it can apply force on others. That is called as a electric charge. Okay, yes, so charge, just I said that here, the charge, when the charge is flowing, then the current is flowing. So now I'm going to tell you how many types of charges are there. So generally we have two types of charges are there. One is a positive charge, one is a positive charge, second one is a negative charge. charge. My question is that who is responsible for electric current? If it is it a positive charge or negative charge? Now we are going to know. So negative charge. So I'm going to discuss here negative charge. For example, if you take conductor, this is my conductor. This is my conductor. In the conductor, for example, general condition, it is consisting of n number of atoms, so n number of atoms, so many atoms are there, in the conductor, like this, general conditions. Okay, now, so this is a, so you know that here, this is the atom. In the atom, the central point is called as the nucleus, which is having a protons and neutrons. For example, which is having three protons and 3 electrons. You know that neutral charge. Initially, all atoms are neutral. Neutral means here number of electrons is equal to number of proton. Number of positive charge is equal to negative charge. So that this is a neutral atom. Net charge is 0. So every atom like this. For example, this is also 3 and 3 electrons and 3 positive charges. Protons. 3 protons and 3 electrons. Like this we are having. Okay. So now, whenever we are giving energy to the electron, for example, we are placing in the atmosphere, So at room temperature, what is the room temperature? 27 degrees centigrade. At 27 degrees centigrade, it is more for the electron. So who give energy? That is the nature. Already this conductor having a temperature 27 degrees centigrade. So this temperature is very high. So this electron, which is revolving around the nucleus and revolving, it gains the kinetic energy. And now it will jump, it escape from the atom. So that and in the first case, atom is neutral. The second case, so who is dominating in this one? Protons are dominating. So here in this we have only 2 electrons are there, 3 protons are there. So that we can say that it is a positively charged body, positively charged atom. So now it is a electron, positive charge and negative charge. Like this here, every atom is like this here. So this is positive and negative, positive, negative, positive, negative, positive, negative, and positive, negative, like this here. Okay, now, so we have like this, we have n number of free electrons are there in the conductors. The general conditions, a general condition at room temperature, this is the position of the conductor. And now this is the position of the conductor, and this is the electrons. So many free electrons are there. Okay, now I can say that here this is a positive charge and negative charge. When we can say the positive charge, so whenever the atom lost the electron, when an atom lost the electron, so we can say that it is a positive charged body. Whenever the atom that gain the electron, we can say that a negative charged body, a negative charged atom, because here, so when it gains electron, who is dominating? Electrons are dominating. So that we can say that it is a negatively charged atom. So if it is lost the electron, we can say that here it is a, who is dominating? A positive charge. So that it is a positive charged atom or body. Okay, like this here we can classify 2 types of charges, negative charge and positive charge. Okay, the electron which is having negative charge and proton having the positive charge, neutron no charge is there. Okay, so my question is that here, who is responsible for the electric current? My question. So electrons, because the positive charge does not move. Okay, so practically the positive charge does not move. Here electrons are revolving, which is moving in the conductor. So that here, so electric current only due to the flow of electrons. So we'll discuss everything detail next coming classes. Okay, right. So I hope you understood what is the positive charge and negative charge. Okay, so what is general condition of the conductor? We are not giving any energy. So already in the nature has energy. Nature has a temperature. Because of this temperature, this is a more for the electron, so that it can jump from the atom, so that if you see the every atom, and this conductor having the so many free electrons, and which is moving in the random direction, which is moving in the random direction. There is no specified direction. So this is general condition of the conductor. Okay, I hope you understood. And positive charge and negative charge. Okay, now, so in the one more important experiment is there in the 10th class, that is a Lorentz-Drude experiment. Okay, in the Lorentz-Drude experiment, and he has conducted an experiment in his lab. So what is the behavior of the electrons? What is the behavior of the electrons in the conductor? Okay, yes. Next one is Lorentz-Drude experiment. Lorentz-Drude experiment. So in his experiment, and he has taken conductor. He has taken conductor. Generally, the shape of the conductor is a cylindrical shape. The shape of the conductor is cylindrical. That's why I have taken a cylindrical shape of conductor. Okay, just I said that here, a general condition at room temperature, it has a positive charge and negative. So many free electrons are there. So many free electrons are there. So many free electrons are there. So n number of free electrons are there. N number of free electrons. So the positive charge does not move. So it is a lattice point. It is a lattice point here. It does not move. Only electrons move. For example, this is moving. This is moving like this, and which is moving and collide with the positive charge. Again, like this. It is moving like this. It is moving a random direction. Random direction. Every electron moving like this only. Okay, this is general condition of the conductor by Lorentz-Drude experiment. Lorentz-Drude experiment. Yes, just I said that in the starting of my class. What is electric current? Electric current is the flow of charge, flow of electrons. Sir, you said that here in this general condition, so electrons are moving or not? Electrons are moving. But the electrons are not moving in the specified direction. For example, so this is electron. So this is electron. So this is the electron, and some electrons. So most of there is a probability to move from left to right. For example, some electrons. Most of the electrons moving from. For example, 20 electrons moving from left to right, and 20 electrons which is moving from right to left. If we calculate net charge across any cross section, net charge is zero. Net charge is a zero. That's why there is a maximum probability is that here net charge is zero, because here they are moving in the different directions. There's probability. For example, they are moving 20 electrons moving from this point in this direction, and 20 electrons which are moving in this direction. What is net charge here? The positive. This is a 20 and minus 20. And what is net charge here? Net charge 0, because here charge is quantized. It follows the one of the property of charge is quantized. Okay, that's why the positive charge and negative. So you can consider this direction. If you consider this is the positive direction and this is the negative direction, and what is the sum of this one here? Net charge 20 minus 20, that is the net charge is 0. Okay, so this is the net charge. Net charge is how much here? Net charge is 0, so that we can say that electric current also 0. Electric current also 0. Okay, right. Now again he has one more experiment, and he has taken so conductor, and he connect these entire conductor across a cell or battery. Yeah, listen here. So this is the plus and minus. It has so many free electrons are there. Like this. Okay, right. So this is electron. Actually, this is electron. And before connecting the battery at cell, this electron which is moving in this direction. this electron which is moving in this direction, and these electrons also, they are also moving in this direction, and these electron also moving in this direction, and these electron moving in this direction. Okay, right. Now, so whenever we connect the, so this is because of who provide this movement for the electron, that is the thermal velocity, thermal, because here already in the nature we have temperature is there, that is the temperature is, that the temperature is thermal temperature or thermal. So because thermal temperature, it has a velocity or speed, that velocity is called thermal velocity. Because of, due to thermal velocity, what is the net charge, what is the current here? Current is zero. Okay, so due to the thermal velocity, net current, the current in the conductor is zero. So okay, because of this one. So whenever we apply, whenever we connect the entire conductor across the battery or cell, and these electron experience a force. These electron experience a force, and this is a so this is the negative charge always experience the force which is opposite to the electric field. Electric field means here, so whenever you provide, so this is the positive charge, entire positive charge is placed, and this is negative charge. Negative charge is placed like this here. Okay, now the electric field always towards from positive to negative. This is the electric field direction. Electric field direction. So okay. So there is a force whenever the electron is placed in the electric field. Who provide electric field? The battery or cell. So whenever we connect the battery across this conductor, and there is electric field created across this conductor. Okay, and these electron having negative charge which experience a force which is opposite to the electric field. That's why which is drifted, yes, which is drifted like this, moving in this direction, and this is also drifted, this is also drifted, and this is also drifted. Yes. Okay, if you observe the position of the electron, now after applying the battery or cell across this one, every electron is moving in a specified direction, So this is the electric field direction, positive negative electric field direction. Okay, electric field direction. So electron is moving opposite to the electric field. What about the positive charge? The positive charge also experience a force which is in the direction of electric field. Just I said that here, who is the root cause of electric current? Charge. Which charge? Negative charge. Who is having negative charge? Electron. But conventionally we follow the direction of the current is always in the direction of positive charge. Conventionally we always consider the electric current is always in the direction of positive charge. Okay, now so, and practically which is the electric current is moving in the opposite to the electric field. Practically current is flowing in the direction of electric current, but conventionally and rules and regulations, so electric current which is flowing in the direction of positive charge direction. This is very, very important. Most of the students may confuse. Sir, electron is not moving, but we can say that the current is flowing in the direction of positive charge. How, sir? Because conventional, this is conventional method. For example, the Indian country, in India we follow. So everybody should follow the what we call transport rules. So we call, when you walk on the road, and definitely we need to walk at the right side, right or left? Right side. Okay, right. And when you go in the USA, they follow the left side. Am I correct or not? Yes, this conventional methods as for the rules and regulations. Same thing also there. As for the conventional rules here, the flow of current always in the direction of positive charge only. That is in the direction of electric field only. Okay, right. So this is a electron flow. The electron flow is this direction. Current is flowing in this direction along the positive direction. So I hope you understood what is the direction of the electric current in the conductor. that is which is in the direction of positive charge. The direction of the current always in the direction of positive charge, but practically in the direction of electric current. So we need to, and remember, this is very important. Okay, right. So this is one of the important. So now we can define the current. Current means here, so if you, for example, when you apply the battery or a cell across this conductor, say if you find the charge across the any conductor, any cross section, so most all electrons are moving in only one direction. If you calculate the charge at any cross section of conductor, net charge is not equal to 0. Net charge is present, so that current is flowing. Yes, so if you want to flow the current in the conductor, so all electrons should move in the specified direction. So an ordered motion direction. In the textbook, they use the one word ordered motion. Ordered motion. The electrons are moving in the ordered motion direction, so that there is a current in the conductor. That is the definition of the electric current. Okay. Now I'm going to calculate the formula. Formulate the electrical current formula. Okay, right. For this I have taken conductor, cylindrical conductor. This is a cylindrical conductor. I have connect the one cell across this conductor. Because of this battery, so there is a electric field across conductor, always positive to negative. Always electric field always positive to negative. Okay. Now electron is moving, which is opposite to the electric field. This is a motion of the electrons, the flow of electrons. Just I said that here the current flow is always in the direction of positive charge. This is current direction. Okay, right. So I want to take the cross section. Any cross section of conductor. This is cross section of area A. Okay. Now Q charge is passing in this cross section in t second. Okay. So how much of charge is passing? So how much of charge is passing in 1 second? That is called as a electric current. That is here. So in 1 second. Okay, now in t seconds. Otherwise, I can in t seconds Q charge is passing. In 1 second, what is the charge is passing? That is we call here I is equal to Q by T. I is equal to Q by T. The charge passing any cross section of conductor in 1 second is called as a current through that conductor. Okay, na? Yes, this is a I is equal to Q by T is the first expression in the electric current. We need to remember. So based on this formula, he may ask questions also. Find out the electric current if charge is given and time also given. Now you should know and unit. You should know what do you mean by unit. Unit is electric current. Actually, electric current is a fundamental unit. Is a fundamental physical quantity. Okay. So from the formula charge, the unit of charge. Already we have studied in the electrostatics. The unit of charge is a coulomb. The unit of charge is a coulomb. By unit of time is a second. Unit of time is second. Coulomb per second. Otherwise, so as for the scientist, so unit of this electric current is ampere. Okay, na? Yeah, as for scientist, so the unit of current is ampere. As for the formula, so electric current is equal to coulomb per second. So can you define 1 ampere current? Can you define 1 ampere current? That is if 1 coulomb of charge is passing in 1 second, so we can say that 1 ampere current is passing through in that conductor. This is one of the important question for the 10th examination. Define 1 ampere current. Define 1 ampere current. How can you define here? If 1 coulomb of charge is passing across a cross section of any conductor in 1 second, so that there is a 1 ampere of current is passing in that conductor. That is a 1 ampere definition. Okay, right. So this is important thing we need to remember. Okay, right. After that here, after that, so up to now we have discussed that what is the charge and what is the direction, what are the types of charges, positive charge and negative charge, and also how many materials we have that should contain the free electrons. Okay, so every metal is not responsible to flow of current. That's why already we have discussed mainly two types of materials, conductor and insulators, and also what is the behavior of the charges electrons in the conductor by conducting the Lorentz-Drude experiment. So he said that yeah, two conditions. He said he explained in two ways. Before connecting the battery at cell, what is the behavior of the electrons? After connecting the battery at cell, what is the behavior of the electrons? Before not connecting the battery, the electrons are moving in the random direction. If you calculate the net charge any cross section, net charge is zero, so that here there is no current in the conductor. Okay, right. After connecting the cell or battery, after connecting cell and battery, so definitely there is a direction. The electrons which are having specified direction, so that net charge is not equal to zero, electric current is flowing in the conductor. So after that we have formulated the electric current. Okay, I is equal to Q by T, and unit is coulomb per second, and one more unit is ampere, and also 1 ampere. Okay, so this is about the current, introduction about the current. Now whenever the electron is moving, nothing but it has a velocity or not. Yeah, definitely the velocity. Now we are going to find out the what is the velocity, what is the velocity of this electron, we are going to discuss. Okay, right. Right. So now heading is a drift speed or drift speed or drift velocity. Drift speed or drift velocity. Drift speed or drift velocity. And if you take conductor, and across this conductor, and I have connected one cell. So it has a free electrons, number of free electrons are there, and these electron, because before connecting the battery or cell, electron is moving in this direction, this electron is moving in this direction, this electron is moving in this direction. Okay, after connecting cell, this is a drifted, like this. So this is a drifted like this, and this is a also drifted towards a positive terminal of the cell, because it experiences a force, because of we have created the electric field, always positive to negative, and is also drifted like this. Listen here, whenever the electron moving from this place to this place, and which is collide with this electron, and this is after moving, this collide with the positive charge. Whenever the electron which is collide with other one, definitely it lose energy or not? Yes, definitely. Whenever the electron which is having a velocity which is always accelerated. Okay now, so this is the body, electron is accelerated and collide. After colliding, the velocity also changes, acceleration also changes, so definitely the speed also reduced. So whenever this colliding this one, speed reduced, again because of electric field, again it is accelerating. Okay now, this electron which is collided with this electron, after colliding this electron, and the acceleration of the the speed is reduced, because of electric field, again it will gain the speed, so again it will accelerate it. Okay, like this the speed of the particular electron which it changes. So we cannot say the speed is not constant. So drift speed, we need to calculate the average speed. That average speed is called as the drift speed. Okay now, because here this is because of before connecting the battery, this electron having some velocity, that velocity is called a thermal velocity, and because thermal velocity which is moving in this direction, which is collide with this electron, and after colliding this electron, the velocity of this particle reduced, and because of reduce here. So when you already now after connecting the battery, because of the electric field again it experiences the force. Because of electric field again it gain the velocity, and velocity increases. Okay, and accelerating, which is accelerating. So decreasing the acceleration, decelerated and accelerated. So now we need to find out the what is the average speed. So if you find the speed, all speeds of the electron, that speed is called as the average speed. That average speed is called as the drift speed. That speed is very small. Okay, so the drift speed of the electron is a 10 power minus 4 meter per second. 10 power minus 4 meter per second. Now we are going to find out the what is the average speed. That average speed is called as a drift speed. A drift speed I want to indicate it later is a Vd. Okay now. So this is a drifted like this Vd speed. This is drifted Vd and Vd. So if you find average of this all speeds, we are getting the drift speed of the electron. Okay, now I want to calculate. So for example, again I have taken conductor. This is a conductor. Across the conductor I connect the battery. Okay na? Yes. So this is electrons. I can represent like this here. All are moving in the specified direction. After connecting the battery, because of electric field present across the conductor, electric field always in the direction of positive to negative. Okay. So every electron having its drift speed like this. Okay. Right. So let us suppose. So I can take the length of the conductor is L. The area of this cross section is A. Area of the cross section of the conductor is A. Okay. Now I want to find out the drift speed in terms of electric current. Okay. Right. For that here I can take for unit volume of conductor. What is the unit volume? In a volume nothing but length into breadth into height. Length into breadth into height. Length is 1 meter, breadth is 1 meter, and height is 1 meter. If we multiply, we get a 1 meter cube. That is called as a unit cube. 1 meter cube. That is a unit volume. So unit volume. This is unit volume. For example, cube is there. This is a cube. Okay. For example, this is a cube is there. Okay. Now, unit volume. Unit cube means here 1 meter. Or 1 centimeter length, 1 centimeter breadth, 1 centimeter height, and multiply all these dimensions, we get the unit volume of the cube. Same thing also we can take a unit volume. For unit volume, number of electrons. For example, later N is the number of electrons for unit volume. So N is the number of electrons for unit volume only. You can also say that this is a electron density. This is also called as a electron density. The small n is called as the electron density. Okay. Now what is the total volume of this conductor? So total volume of conductor. Total volume of conductor. Total volume of conductor is area into length of the conductor. This is the total volume of the conductor. But I need to find out the total number of electrons per total volume of the conductor. Just multiply. For unit volume of electron, we get total number of electrons. Okay, that is the total charge or the total electrons. Total number of charges or electrons. That is just multiply n into total number of electrons. So total number of electrons. That is n into A into L. This is the total number of electrons or n into A into L. So for every electron having the charge Q or E. Okay now. For each electron charge is a Q. For total number of electrons, for n electrons here, just multiply Q and we get total charge. So that total charge is equal to total charge in the conductor is equal to, I can call Q, capital Q is equal to n into A into L into small q. That is a total charge in the conductor. So you know that what is the current? Current is equal to total charge by time. Okay. Yes, I want to substitute here. So you know what is the time here? So time, according to the kinematics. According to the kinematics, That is, velocity or speed, drift speed. Speed is equal to distance covered. How much distance covered by each electron is L distance. What time here T. Okay. Now I can write from this T. T is equal to L by VD. L by, we just substitute here. So I is equal to, what is the Q? NALQ by, what about this T, L by, and which is VD is going up. L get cancelled. So I is equal to N into A and Q into VD. So in some textbooks, he may also given in the place of Q, and he has given NaE also. E is the charge of electron. Charge of electron. From this I can write VD is equal to I by NaE is a formula for drift speed of the electron. So this is very, very important. So these calculations, derivation also very, very important for 10th examination. For 10th examination, derivations are not important, and 99.9% this question never will come in the examination. So but we should remember this formula. He may give some problems also. Okay na? So drift speed, find the drift speed when the current is given, current in the conductor is given, number of electrons per unit volume is given, is area of the conductor is given, charge of electron. You know what is charge of electron? The charge of electron is 1.6 into 10 power minus 19 coulombs. Coulombs. So we need to remember it is standard value. For every electron having charges, how much charge is there? Already we have studied electrostatics. Okay, one electron is the charge in one electron is equal to 1.6 into 10 power minus 19 coulomb. Just you substitute and we get the everything. Okay, right. This is about the today class. Okay, I hope you understood. And if you are not understanding, if you have any confusion, again listen my class once again, because I upload this entire concept in the YouTube channel. Is a free of cost. One more thing I have to say, and already have started the classes, IIT classes. They are not free of cost. If you want to listen my classes, so this is basically totally IIT classes based on intermediate syllabus. Okay, so if you want to listen my classes, enroll first your name by contacting my number. You know my number, and I will keep my number in the description, and please call to me and enroll your name. So already I have started classes. Most of the people have joined my class. They are also very happy. Okay, and so I hope most of the peoples join in my channel and in my course also. So it is very, very useful. At the end of my course, definitely we are very happy. Okay, please enjoy my classes, and I will post everything, whatever the concept or chapters are there in the state, Telangana state, or on Andhra Pradesh, and everything I will post in my channel. It is a free of cost and learn. So after completion of these entire chapters, again I will discuss the most important questions. The previous questions also I'm going to discuss. Some problems also I will discuss. Okay, and follow. And next class we'll discuss next concepts in the next class, next sessions. Okay, thank you, Anandal.